Welcome to the deep dive, everybody. Ready to explore the fascinating world of memory?
Always ready for a deep dive into the brain.
Well, you might be surprised to hear that our understanding of how memories form is pretty recent, really.
Yeah, neuroscience is a relatively young field when you think about it.
Right. The discovery of something called long-term potentiation, or LTP, back in 1973 was a total game changer. It's kind of crucial for how we learn and remember. And get this.
It has a pretty cool backstory.
It totally does. Rainy day brunches, scientists chuckling over data, even film rolls strung down a whole stairwell.
Sounds like a movie.
Seriously. So picture it. 1973, Oslo, Norway. We've got these two neuroscientists, Tim Bliss and Terje Lomo, just doing their thing in the lab.
Pioneers.
Totally. And here's the thing. Lomo wasn't even looking for LTP.
He was on a different track entirely.
Oh, yeah, completely different. He was studying something else in the hippocampus, which is like memory central in mammal brains.
Right, the hippocampus. And what was he studying there exactly?
He was looking at whether repeated electrical pulses, kind of like mimicking those signals neurons send,
See if they'd make the hippocampal neurons more sensitive.
Exactly, like priming them for action. So they were zapping rabbit brains.
Zapping rabbit brains.
And then boom, they see something wild on that oscilloscope.
What did they find? What was the big aha moment?
Well, they found that when one neuron signals to another often enough, the receiving neuron, it actually gets more responsive to those signals in the future.
And not just for a bit, but for hours and hours.
Exactly. This lasting change, that's what we call LTP.
The birth of a scientific revolution.
And you won't believe this. They were photographing every single response on these, old school oscilloscopes.
No way, really?
Yep, then hanging those film rolls to dry from the top floor all the way down to the basement of their institute. It's crazy.
Talk about dedication to the scientific process.
Seriously, it was like a scene from a vintage science fiction movie with film strips everywhere.
But hey, that dedication paid off, right? Their 1973 paper, the one published in the Journal of Physiology, that was huge for neuroscience.
Huge, it really was. Though things weren't always smooth sailing after that.
Really? What happened?
Well, it turns out those early LTP results, those were kind of tricky to replicate at first.
Oh, so they hit a snag.
Kind of. They later figured out that the stress levels of those rabbits, the ones they used in later experiments, those actually played a big role.
Stress affecting the brain. Not surprising.
I know, right? But it was interesting. They saw that stress could actually enhance LTP in some parts of the hippocampus, but suppress it in others.
So already they're finding these intricate details, these nuances.
Exactly, showing how complex and sensitive this whole LTP process really is. But even with those early hiccups, their work sparked this huge wave of interest in the field, didn't it?
Oh, absolutely. By the 1980s, technology had caught up a bit, and researchers could start digging deeper into those LTP mechanics. They were using slices of the hippocampus, kept alive outside the brain.
Wow, a tiny brain lab in a dish.
Pretty much. And it led to some major discoveries, like those two key receptors involved in LTP, AMPA, and NMDA receptors.
Right, those are important.
And they found this molecule, glutamate, that's released from the sending neuron, that's essential for LTP to happen.
Okay, I feel like we're about to get into some serious brain chemistry here. Can you break this down for me?
Sure. So imagine neurons are like these intricate electrical circuits. And those receptors, think of them as specialized gatekeepers on those circuits. Glutamate, that's the key that unlocks these gates.
I'm following so far.
Okay, so when glutamate binds to those AMPA receptors on the receiving neuron, it opens channels. And these channels allow sodium ions to flow in. This flow changes the electrical charge of the receiving neuron, making it more likely to fire.
So it's like this sudden surge of electricity through the circuit.
Exactly. And if this happens often enough, another receptor, that NMDA receptor, gets activated. This sets off this whole cascade of events that ultimately strengthens the connection between those two neurons. That, my friend, is long-term potentiation in action.
Wow, it's like building a stronger pathway for information to flow. But did researchers know if this actually had an impact on learning in, living beings?
That's where things get really interesting. Enter Richard Morris and his maze running rats.
Those experiments are classic.
They are. So he shows that by blocking those NMDA receptors in rats, he could actually mess with their ability to learn how to navigate a maze.
So messing with LTP directly affected their learning in a real-world task.
Exactly. That research was huge. It provided this crucial link between the molecular mechanisms of LTP and actual learning, memory formation, the whole shebang.
That's incredible. So it's not just about these signals and molecules. It's about real-world learning and remembering. This LTP is happening at the synapse, right? But what about the neuron itself? Does it actually change because of LTP?
Great question. That leads us to the work of Kristen Harris and those tiny little protrusions on neurons called dendritic spines. Remember those?
Vaguely. They're like those tiny fingers reaching out to connect with other neurons, right?
That's them. And Harris, she discovered something wild. LTP actually makes those dendritic spines physically grow.
You're telling me the neuron itself changes shape.
You got it.
Yeah.
It's like this, imagine you're building a factory, right? You need space for all the machinery and workers.
Makes sense.
Well, neurons are similar. Those dendritic spines, it's like building an extension onto that factory. They make space for all that molecular machinery that keeps those stronger connections going. And guess what's driving this whole expansion? LTP.
Mind blown. So every time we learn something new, the connections between neurons get stronger, and the neurons themselves change shape to handle all that new activity.
That's the amazing thing about the brain. It's constantly adapting. And it really highlights why repeated exposure and spaced repetition are so important for learning. Each time we revisit something, those connections get a little stronger, those spines grow, and the memory gets more and more embedded in our brains.
So cramming for a test might not be the best strategy after all.
Probably not the most effective. Spaced repetition, where you come back to the information over time, that's what lets those connections really solidify, those spines to get nice and big.
Okay, so far we've been hanging out in the hippocampus. Is this LTP thing only happening there, or is it more widespread?
That's a fantastic question, and honestly a common misconception. The hippocampus is a big player in memory, that's for sure, but LTP isn't just limited to that one spot. We see it happening in other parts of the brain too, like the amygdala, for example.
The amygdala, that's the emotion center, right?
Exactly, especially for processing fear. And guess what? It shows LTP too.
So even our emotions are shaped by this.
Precisely. And it's not just those emotional centers either. The cerebral cortex, which is where all those higher level thinking skills happen, like decision making and language.
That shows LTP too.
You bet. So this process is way more far-reaching than most people realize, but it's not even confined to the brain itself. It can actually happen in other parts of the nervous system too, like the spinal cord.
Wait, the spinal cord? I thought that was just about reflexes and, carrying signals around. What's LPP got to do with that?
Well, the spinal cord does do those things, but research by Michael Salter and others, it suggests that LTP in the spinal cord could actually contribute to chronic pain.
That's interesting. And it makes me wonder, if LTP is involved in things like chronic pain, which obviously isn't good, could we use this knowledge to, improve things, enhance memory, treat different conditions, maybe even boost learning in a really targeted way?
Those are some really excellent questions, and they're at the heart of a lot of current research. The potential is huge, but so are the challenges. You see, because LTP is so widespread and so fundamental to how the brain works, trying to manipulate it requires incredible precision. We're still figuring it out.
That makes sense. I wouldn't want someone to accidentally boost fear memories or worsen pain while they're trying to improve my thinking skills.
Exactly. And then there's the ethical side of things, which is a whole other conversation. But we've covered a lot of ground already. Before we move on, maybe it'd be helpful to recap those key LTP takeaways. What really stands out to you?
Well, I think the big thing is that LTP is this incredible foundation for learning and memory. It's this intricate dance of molecules that strengthens connections between neurons, making them super responsive to those signals.
You got it. And we can't forget that this process involves not just electrical and chemical changes, but structural ones too. Those dendritic spines actually growing larger.
Right. It's almost like they're reinforcing a bridge to handle more traffic.
Oh.
The stronger the connection, the easier information flows through those pathways, and that's how memories become solid.
Great analogy. And remember, this isn't just happening in the hippocampus, it's happening all over the brain, even in the spinal cord. It's involved in everything from fear and pain to super high-level thinking.
It's mind-blowing to think that something so fundamental to who we are, how we learn, how we remember, even how we feel, it all boils down to these tiny processes happening at a cellular level.
It really makes you appreciate the complexity of the brain, doesn't it?
It truly does. And we're only scratching the surface of understanding it all.
We are. Just imagine what future discoveries await us.
I can't wait to find out.
Oh, me too. But for now, let's take a short break and we'll be right back with more on the fascinating world of LTP and its implications. So before the break, we were talking about, all the potential of LTP. Could we actually harness it for good? There's a ton of research going on right now.
It's a really fascinating area.
Yeah.
I mean, could this lead to some, like, crazy breakthroughs down the line? Personalized memory enhancement, maybe? Or super targeted treatments for anxiety or chronic pain? It feels like the possibilities are endless.
The future of memory research is definitely exciting, that's for sure. And maybe a little daunting, too, you know? It's like we've stumbled onto this incredibly powerful tool, but we're still trying to figure out how to use it responsibly without any unintended consequences.
I get that. It's like those sci-fi movies where they discover some amazing tech, but then things go haywire because they didn't really think it through.
Exactly. That's why those ethical considerations are so crucial. We have to really think about the potential downsides, the unintended consequences of messing with something as fundamental as LTP.
Right, like the whole playing God thing people talk about with new technologies.
Yeah.
But let's focus on the positive for a second. What are some of the areas where researchers are seeing promising results with LTP? You know, things that could actually help people.
Well, one area that's looking really promising is cognitive enhancement. There are a bunch of studies going on right now exploring ways to boost LTP in specific brain regions. The idea is to improve memory and learning.
So is this like brain boosting pills or something? Where do I sign up?
Not quite that simple. While there are some supplements and drugs being studied, the focus is really more on understanding how LTP works naturally and figuring out how to leverage that. Think more along the lines of lifestyle changes, brain training exercises, maybe even personalized interventions based on someone's individual brain activity.
Okay, that makes a lot more sense. Working with the brain's natural abilities rather than trying to force something artificial. What about those conditions we talked about earlier, anxiety and chronic pain? Is there any progress being made there?
There is. Remember how we were saying that LTP might actually play a role in chronic pain? Well, researchers are looking at ways to disrupt or even reverse LTP in the spinal cord to try and alleviate those chronic pain conditions.
Instead of just masking the pain with medication, they're going after the root cause.
Exactly. And for anxiety disorders, researchers are investigating how LTP might be involved in those fear memories, how they form and get stronger. You know, if we can understand how those fear memories get so ingrained, then maybe we can develop more effective therapies to help people overcome anxieties and phobias.
It's wild to think that something as, I don't know, seemingly simple as being repeatedly exposed to something you're afraid of, that could actually be driving those deep-seated anxieties through LTP. Makes you wonder, though, could we also use this knowledge to, like, unlearn those fear connections? Weaken them somehow?
You're on the right track. That's exactly what therapies like exposure therapy and cognitive behavioral therapy are trying to do. By gradually exposing people to their fears in a safe and controlled environment, the goal is to weaken those LTP-driven fear associations.
So, in a way, we're kind of hacking the brain's natural learning processes to overcome these issues.
That's a great way to put it. We're leveraging the brain's plasticity, its ability to change and adapt, and this is where things get really cutting edge. One of the most exciting areas of LTP research right now is in neurotechnology.
Neurotechnology, that sounds super futuristic.
Think brain-computer interfaces, neurostimulation techniques, even virtual reality environments that are specifically designed to enhance LTP and promote neuroplasticity.
So are we talking about wearing brain-boosting helmets or using VR to, like, rewire our brains? Is that where this is going?
We're not quite there yet, but the potential is definitely there. Researchers are exploring ways to use non-invasive brain stimulation techniques like transcranial magnetic stimulation, or TMS, to actually modulate LTP in very specific brain regions.
That sounds like something straight out of a sci-fi movie.
It kind of does, doesn't it? And the applications are pretty amazing. For example, some research is looking at using TMS to try to enhance memory in people with Alzheimer's, stroke, or traumatic brain injury.
That could be life-changing for so many people. But I imagine there are some big ethical questions that come with such powerful technology, right? Like, who gets access to these treatments, and what are the potential downsides?
You're absolutely right. Those are really important questions that scientists and ethicists are working through right now. We need to be careful about the potential risks and benefits, and also make sure these technologies are accessible to everyone, not just a select few.
Right, making sure these advancements actually benefit all of society.
Exactly. It's definitely a complex landscape, and we have to proceed with both enthusiasm and caution. But I'm really optimistic about what the future holds. The more we understand about LTP, the better equipped we'll be to develop effective and ethical ways to enhance cognitive function, treat those neurological and psychological disorders, and really unlock the full potential of the human brain.
It's an exciting vision of the future, that's for sure. But I think it's also important to remember that LTP isn't just this abstract concept, right? It's happening in our brains right now, every single day.
Absolutely, it's ongoing. Every time you learn something new, make a new memory, have a new experience, LTP is at work.
So as we're talking, as I'm trying to remember what we talked about earlier, my neurons are firing away, strengthening those connections, and actually reshaping my brain.
You got it. It's a dynamic process, always changing, always adapting, and it's happening at this incredible microscopic level.
It really is humbling when you think about it.
Uh,
And it makes you realize that we're all capable of learning, growing, and changing throughout our lives.
Absolutely. The brain is anything but static. It's constantly adapting and evolving based on our experiences. And that's what makes LTP so fascinating to study. It's a glimpse into what makes us human, our capacity for learning, memory, and change.
You know, as we've been talking, I've started to see LPP not just as this scientific phenomenon, but almost as a metaphor for life itself. It's about building connections, strengthening them,
Yeah.
adapting to new situations, and constantly evolving.
That's a beautiful way to put it. And it reminds us that even small, seemingly insignificant experiences can have a lasting impact on our brains, shaping who we are and who we become. It's a reminder to cherish those moments, to embrace learning new things, and to never stop exploring the amazing potential of our own minds.
I love that. Well, I think we've reached the end of our deep dive into LTP.
It's been a pleasure exploring this topic with you. I hope you've gained a better understanding of LTP and what it means for learning, memory, and really everything we do.
I definitely have. And I'm excited to see what the future holds for LTP research, all those possibilities we talked about.
Me too. But for now, let's leave our listeners with something to think about.
Okay, what do you have in mind?
Now that you know about LTP, try paying attention to your own learning experiences. Notice how repetition and coming back to information over time really helps it stick. And remember, every new memory, every skill you learn, every connection you make, it's all thanks to the incredible plasticity and adaptability of your brain.
That's a perfect way to end our deep dive. It's a reminder that we're all capable of continuous learning and growth, and that the journey of discovery never really ends. Thanks for joining us on this incredible exploration of LTP.
It was my pleasure. Until next time, keep those synapses firing and those dendritic spines growing.
Welcome back to the deep dive. We've been exploring this incredible world of long-term potentiation, LTP, and how it's basically the foundation of our ability to learn and remember.
It's been quite a journey, hasn't it, taking this deep dive into those microscopic workings of our brains.
It really has. We've talked about the science, the history, even what the future might hold for LTP research. But what I keep coming back to is like how this actually connects to our everyday lives, How does this actually affect us?
That's the beauty of it, right? It's not just some abstract idea. It's happening in your brain right now as we're talking.
So while I'm trying to remember everything we talked about in the last section, all those neurons are firing, making those connections stronger, and literally changing the shape of my brain. Is that really happening?
That's exactly what's happening. Every time you recall a fact, every time you learn a new skill, or even experience something new, those tiny little dendritic spines are branching out, making connections, and getting stronger. It's a constant dance happening in there.
It's amazing to think about, honestly, all that complexity happening at such a tiny scale. But how does this translate into, like, actually improving our memory or getting better at learning new things?
Well, remember how we were talking about spaced repetition and how important it is to revisit information over time? Every time you do that, you're giving those synapses a little workout, basically. You're strengthening those connections, making it easier to pull up that information later on.
So it's really not about cramming everything in at the last minute, huh? It's more about giving our brains time to really process things, to solidify those memories.
Exactly. Think about it like building muscle. You have to consistently challenge it to make it stronger. Same thing with our brains. And here's a little tip. Next time you're trying to learn something new, try explaining it to someone else.
Oh, that's a good one. I've heard that teaching something is one of the best ways to learn it yourself.
And there's a reason for that. When you explain something to someone else, you're forcing your brain to retrieve that information, organize it in a way that makes sense, and explain it clearly. That process just strengthens those connections even more, makes the memory that much more accessible.
So we're actively engaging those LTP pathways and solidifying the information. Are there any other strategies we can use to, like, enhance LTP and become better learners?
Absolutely. One of the most important things is getting enough sleep. Sleep is super crucial for memory consolidation. It gives your brain a chance to process and store all the information you've taken in during the day.
There's a reason I love sleep so much. It's not just about feeling rested. It's about letting my brain do its thing.
Exactly. And don't underestimate the power of physical exercise either. When you exercise, you're increasing blood flow to your brain, which helps boost those all-important neurochemicals that support LTP and just overall brain health.
So if you want to be a mental powerhouse, you got to take care of your physical health too.
It's all connected. A healthy body supports a healthy brain, and a healthy brain supports a healthy body. It's a two-way street. And there's one more thing that's often overlooked: mindfulness and meditation.
Okay, I'm curious. How does that tie into the LTP?
Well, mindfulness practices, things like meditation, have actually been shown to increase gray matter in the hippocampus. And that's like the memory hub of the brain.
Wow, so by calming our minds and focusing, we're actually strengthening those memory centers.
Pretty cool, right? And there's more and more research showing that mindfulness can also improve attention, focus, and emotional regulation, all of which play a role in learning and how well our brains function.
It's like we're training our brains to be more efficient, more adaptable, more resilient, really.
Exactly. And it all circles back to that idea of LTP as this metaphor for life. It's about being open to new experiences, challenging ourselves, and always looking for opportunities to learn and grow.
I love that. It really is a beautiful way to think about it. Our brains are constantly changing and adapting based on what we experience. And we can actually influence that process by the choices we make and the things we do.
That's the amazing thing. The more we learn about how our brains work, the more we can take charge of our own, cognitive destiny. We have more control than we realize.
Well said.
Yeah.
I think our listeners have a lot to think about after this deep dive into LTP.
I hope so. And I really encourage everyone to keep learning about this stuff. The more we understand about LTP, the more we unlock those secrets of learning and memory and really the incredible potential of our brains. There's so much left to discover.
And on that note, it's time to wrap up another deep dive. Thanks for joining us on this exploration of the fascinating world of LTP.
Until next time, keep those synapses firing.